In this video, we are going to discuss grand test paper number 7, that is on complete syllabus. Now, go through the first question once. An AND gate can be prepared by respect to use of. So here, among these four, NAND gate is the universal gate. NAND and NOR gates are called universal gates, so that we can prepare any gate by using either NAND or NOR gate or combination of these two, so that these two are called universal gates. So both options are correct. Next one. The potential difference V is applied at ends of a copper wire of length 1 meter and diameter D. On doubling the diameter D, drift velocity is. So drift velocity formula. So voltage, potential difference by N into E into A into L. So here voltage V. But in this formula, there is no dependency on diameter. So that we can conclude that if you doubling the diameter, then drift velocity formula is Vd equal to V by rho L Ne. So this is a potential. So here there is no diameter component. So we can conclude that drift velocity is independent diameter if potential is constant. So if potential is constant, then only we need to specify like that. So if electric field is constant, then we need to write this potential as so electric field into distance. So that is different. Here, which one is constant? Potential is constant. So that we need to write the drift velocity equation in terms of potential. So that if you write drift velocity formula in terms of potential, that is independent on diameter. So drift velocity does not change if you increase the diameter also. Next one. The graph of ln of r by r naught, ln of a. Here r is radius of the nucleus, a is mass number. So what is the relation r equal to r naught into so a power 1 by 3. This is the basic relation. Now from this one, r by r naught equal to a power 1 by 3. So apply both sides log r by ln of r by r naught, that equal to ln of a power 1 by 3. So these two are directly proportional, so that if you draw the graph between these two, then that should be a straight line. Next, a current carrying rectangular coil placed in a uniform magnetic field in which orientation the coil will not tend to rotate. So will not tend to rotate. That means the rotation should be 0. Now, what is the torque formula? NIAB sin theta. NIAB sin theta. So, in which case torque will be there? Will not tend to rotate means there should be a torque. No. In which case torque should be there? So, what is theta here? Theta is the angle between aerial vector and magnetic field. Aerial vector and magnetic field. Now, aerial vector means always perpendicular to the surface, like this. This is the aerial vector for this surface. Now, if a coil is parallel to the magnetic field, if coil is parallel to the magnetic field, then theta equal to 90. Next one. Field is perpendicular to the magnetic field, then theta equal to 0. Because the aerial vector is perpendicular to the surface. So just remember that one. So here it is parallel means don't write theta as 0. So it is a magnetic field is parallel to the plane of the coil means so magnetic field direction, aerial vector are perpendicular to each other. Next, magnetic field is perpendicular to the plane means theta should be 0. Next, so theta is 45 here given. Next, always in any rotation. Now, so finalize torque will be at which case torque will be 0. So will not tend to rotate means torque should be 0. So it is not rotating means torque should be 0. Now in which case torque is equal to 0? For second option torque is going to be 0. If theta equal to 0, then entire this torque will be 0. Sin 0, 0. So that entire torque equation becomes 0. Next one. Magnetic field due to a straight conductor of a uniform cross section of radius A carrying current, a steady current, is represented by. So the magnetic field inside and outside the conductor. Magnetic field inside the conductor is directly proportional to R. Outside the conductor is inversely proportional to R. So that first option is the correct one. Next one. The following graph, a particle moving in a x-axis, along x-axis, position time graph is given. Then what is the correct statement among these four? So particle continuously going in positive x direction. Continuously going in a positive x direction. Next, particle is always rest. So this is wrong option. Next one. Velocity of the particle increases up to time t0 and then becomes constant. Here slope is there, so velocity increases. After that constant. After that velocity decreases. First velocity increases, constant. After that decreases. So this is also wrong. Now particle is continuously going in a positive x direction. So you cannot say, because it is velocity increases for some time. After that velocity decreases. We cannot say that is always moving in a positive x direction. So this is also wrong. Go with fourth option. A particle moves with a constant velocity up to time t0 and stops for time t0 for some time t0. After that returns back. So exact case that matches this diagram is this one only. So particle will move with constant velocity up to t0. After that for time t0 that is at rest. Next after that so that is in reverse direction, that is traveling in a reverse direction or return back. So again it reaches origin, so that we need to say that return back. Next, if a PN junction diode is connected to a circuit, then which one is we need to select? The potential is same everywhere. P type is a higher potential than N type. There is an electric field in the junction from N type to the P type. So junction. So this is P type, this is N type. So junction potential or junction electric field is from negative to positive only, opposite to the original direction. So we need to select third option. So within the barrier, electric field is opposite to the original direction, or that is directed from negative side to positive side. Within the barrier only, that is possible within the barrier. Outside of the barrier, from positive to negative only. So you have to select the third option as the correct one. Next one. Magnet of vibration magnetometer is heated so as to reduce magnetic moment by 36%. By doing this, periodic time of the magnetometer will be time period of the magnetometer. Time period. So what is the basic formula for time period? 2 pi root I by mv. This is the time period in the case of magnetometer. 2 pi root I by mv is the time period. Now, so which one increases? Magnetic moment reduced by 36%. Let initial magnetic moment is 100. Next, final magnetic moment becomes that reduced by 36%. That means 100 minus 36 equal to 64. Now, what is the relation between time period and magnetic moment? Time period is inversely proportional to square root of magnetic moment. Now, T2 by T1 can be written as M1 by M2. T2 by T1 equal to square root M1 by M2. Now, substitute this one. So, T2 by T1 equal to square root M2 is 64, M1 is 100. So, 100 by 64, that equal to 10 by 8. Now, what we have to calculate? So, time period change. Now, so this is T2 by T1. Now, 1 minus T2 by T1 equal to 1 minus 10 by 8. That equal to 2 by 8. So 1 minus T2 by T1 is nothing but a change in time period by initial time period. So change in time period by initial time period can be written as, so here 4 times 1 by 4 or 0.25 or 25%. 25%. So increases or decreases. So time period and magnetic moment are inversely proportional. Na? So here magnetic moment decreases. Magnetic moment decreases means the time period need to increase. So increases by 25%. Next, electromagnetic wave travels along positive z-axis. Now, the varying fields would generate the such wave. So electromagnetic wave direction is given by V equal to E bar cross V bar. So V should be along z-axis. So V అనే z-axis లో ఉండాలంటే సో ఈ రెండు ఎలా ఉండాలి IJ ఉండాలి IJ ఉంటేనే ప్లస్ z వస్తుంది సో డైరెక్షన్ ఫైనలైజ్ చేయాలంటే ఇది ఒకటే ఫార్ములా ఉంది V ఈక్వల్ టు E క్రాస్ B నాట్ ఫర్ మాగ్నిట్యూడ్ దిస్ ఇస్ ఓన్లీ ఫర్ డైరెక్షన్ ఓన్లీ సో I క్రాస్ J దట్ మీన్స్ ఎలక్ట్రిక్ ఫీల్డ్ I డైరెక్షన్ లో ఉండాలి మ్యాగ్నెటిక్ ఫీల్డ్ J డైరెక్షన్ లో ఉండాలి సో x యాక్సిస్ ఏమో ఎలక్ట్రిక్ ఫీల్డ్ మ్యాగ్నెటిక్ ఫీల్డ్ y యాక్సిస్ నెక్స్ట్ in a perfectly elastic collision kinetic energy remains always constant. Kinetic energy first increases, after that decreases. So initial kinetic energy is equal to final kinetic energy. Next, initial kinetic energy is greater than final kinetic energy. Next, the kinetic energy remains constant. No, because kinetic energy of some particles decreases, for some particles some objects increases, but total kinetic energy is constant, not individual. Total should be constant. Next, a uniform cylinder of mass 1 kg and radius 2 cm is rotating about its main axis at the rate of 4 rpm. Now constant torque is applied to stop it after 2 pi revolutions. Now write down the given quantities. Mass is given as 1 kg. Radius is given as 2 cm. 2 into 10 power minus 2 meter. Next one. It is rotating about main axis at a rate of 4 rpm. So initial angular velocity is 4 rpm. Revolution per minute. That means 4 into 2 pi by 60 radian per second. Next. Omega equal to 0. Now, so what is the time taken? Distance displacement, angular displacement is given as 2 pi revolutions, or 2 pi into 1 revolution means 2 pi radians. So just convert this one into radians. 2 pi revolution means 2 pi into 2 pi radians. That means 4 pi square radian. So these are the quantities: mass, radius, initial angular velocity, final angular velocity. Angular displacement is given. Now we need to calculate for torque. Torque equal to I alpha. I can be written as this is a uniform cylinder. So 1 by 2 mr square is the moment of inertia. Alpha angular acceleration, final angular velocity minus initial angular velocity by 2 into displacement. This is from v square minus squares also there. V square minus u square equal to 2as. Like that, if you apply for rotational motion, final velocity whole square, initial velocity whole square by 2 into theta is the angular acceleration. Now substitute and solve. 1 by 2 into m value 1 r square 4 into 10 power minus 4 omega 2 square. So whole square of this one. So this is 30 times. So 4 pi by 30. 4 pi by 30 whole square minus 0 by 2 into angular velocity theta is again 4 pi square. Now solve this one further. Just direct substitution only, direct solve only. Solve this one further, then you will get 4.44 into 10 power minus Newton per meter. Next. Next one. Moment of inertia of a uniform circular disc is minimum about which axis? So moment of inertia is always a minimum about an axis passing through its center of mass. So here four different axes are there. So this axis is passing through center of mass, so that moment of inertia is minimum about that axis only. Next. So which among the following statement is incorrect regarding a uniform spherical shell? Uniform spherical shell. Now go through the each point. Inside the shell, the gravitational potential is zero. Inside the shell, the gravitational field is zero. Inside the shell, the gravitational potential is same everywhere. Inside the shell, gravitational field is same everywhere. Now, which one you are going to select? So inside the cell, gravitational field is always zero. Gravitational field will be zero, not potential. Potential is constant. So this one is correct. Next. So inside the cell, so if field is zero, then potential is constant. This one also correct. Next one. Inside the cell, gravitational field is same everywhere. That is zero only. No? So that is same everywhere. So all these are correct. Now, what you have to select? Incorrect statement. We need to select incorrect statement. So incorrect statement is gravitational potential is zero inside the cell. That is the incorrect statement. So first option is the correct one. Next. Breaking stress of the wire is depends on. So breaking stress depends only on material like Young's modulus or bulk modulus or density. Breaking stress is directly depends on the material of the wire only, not on dimensions. So third option is the correct one. Next, two liquids are same volume but different densities rho 1, rho 2 are mixed together. Then density of the mixer. So density formula total mass by total volume. Mass can be written as, so here two different are there, m1 plus m2 by total volume v1 plus v2. Now, so here what is at the same volume? That means v1 equal to volume, v1 equal to v2. So mass can be written as density into volume, rho 1 into v plus second mass rho 2 into v by both volumes are equal, v plus v. So then you will get rho 1 plus rho 2 by 2. Take v as common and cancel, then you will get that equation. Rho 1 plus rho 2 by 2. Second option. Next. A ball is thrown downward with some velocity into viscous liquid. Then which of the following curves may represent the possible variation of velocity versus time? So here for viscous fluid, if it is moving downward, velocity is going to increase. After that, after some time, that becomes constant. So velocity is going to increase. After that, that becomes constant. So third option is the correct one. Next one. A cricket ball hit at 30 degrees with horizontal, the kinetic energy K. Now, so assume that a cricket ball is moving like this. So at this location, velocity is let it be u. Kinetic energy is given as K. Now, how much is the kinetic energy? 1 by 2 mu square is the kinetic energy. That is at location A. Now, at highest point, velocity is u cos theta. At highest point, velocity is how much? U cos theta. Now, what is the kinetic energy at that location? Kinetic energy at that location, let it be K1, 1 by 2 into m into velocity whole square. That means u cos theta whole square. That equal to 1 by 2 into m u square cos square theta. 1 by 2 mu square is how much? K. K into cos theta. Theta is how much? 30 degrees. Cos 30 whole square. That equal to K into cos 30 can be written as cos 30 root 3 by 2. So root 3 by 2 whole square. That equal to 3k by 4. 3k by 4 is the answer. This one. Next one. A piece of metal is heated in furnace flame. The first becomes dull red. After that, it becomes reddish yellow. Finally, it turns into white hot. Now, the correct explanation for the above observation is possible with the help of. So So here red colors, there is a change in color, na? That means there is a change in wavelength. So wavelength and temperature relation, which of the following gives wavelength and temperature relation? Means a displacement. So here color indicate that there is a change in wavelength. So wavelength and temperature relation is given by means displacement. Next one, molar specific heat at constant pressure for an ideal gas. That means Cp is given as 7/2 into R. Now ratio of specific heats at constant pressure to the constant volume. Cp is given, Cv is how much? 5/2 R. Now ratio of these two, 7/5. So Cp is given, just I am writing Cv from that one. So Cp minus Cv formula is R only. So use this relation and write down Cv value. If it is 7/2, Cv should be 5/2. Then Cp by Cv equal to 7/5. Next, efficiency of a Carnot engine operating with reservoir temperature 100 degrees centigrade and -7 degrees centigrade will be. So efficiency formula 1 minus T2 by T1, that equal to 1 minus T2 value, final temperature T2, that is 273 minus 7 by T1 value 100, 273 plus 100. How much it is? 1 minus, this can be written as take LCM. 373 minus 266. So by 373, how many options are there? Second and fourth. You have to select one of these two. Now 373 minus 266. 373 minus 266. So 7, no, 16, 10, 107. So theta equal to 107 by 373. So 107 can be written as 100 plus 7. So second option is the correct one. Next. So equation y equal to a sin square omega t minus kx. Here square is there. So now first we need to eliminate that square. To eliminate that square, cos 2 theta formula. Cos 2 theta formula is cos square theta minus sin square theta. Or if you write cos square theta as 1 minus sin square theta, then you will get 1 minus 2 sin square theta. This is also other formula for cos theta only. Cos 2 theta formula. Cos 2 theta is 1 minus 2 sin square theta. Now from that one, sin square theta is sin square theta equal to one minus cos 2 theta by 2. This is the formula for sin square theta. So rewrite this value like this. Or 1 by 2 in 1 by 2 minus 1 by 2 cos 2 theta. Now apply this formula to this one, to this original equation. Then y can be written as y equal to, so 1 by 2 sin square theta, sin square omega t can be written as a into sin square omega t can be written as 1 by 2 minus 1 by 2, 1 by 2 minus 1 by 2 cos 2 into, so what is the theta value? Omega t minus kx. Now rearrange. A by 2 minus a by 2 cos 2 into omega t minus kx. This is y value. Now from this one, what is the amplitude of the motion? A by 2 is the amplitude. Now what is the angular velocity? 2 omega. Angular velocity is 2 omega. So amplitude A by 2 and frequency. So this is omega dash. So frequency F equal to omega by 2 pi. What is the omega value here? 2 omega. 2 omega by 2 pi. That equal to omega by pi. Omega by is the frequency. A by 2 is the amplitude. Third option. A by 2 is the amplitude. Omega by pi is the frequency. Next. When a sound wave is refracted from air to water, so any wave is traveling from one medium to other medium, then which one is constant? Frequency is constant in any lesson, either light lesson or a sound waves lesson. If a light wave, any wave travels from one medium to other medium, then which one is constant? Frequency is constant. Next. A simple pendulum is suspended from ceiling of a car, accelerating with acceleration g by 2. Then length of the pendulum is L. Time period of oscillation is time period formula is square root 2 pi root. So L by square root a square plus g square. If it is accelerating, then general formula is 2 pi root L by square root a square plus g square. Now substitute the a value. So 2 pi square root L by square root a square. Acceleration is how much? G by 2. So g square by 4 plus g square. Now t equal to 2 pi square root L by now 5g square root 5g square by 4. That equal to 2 pi square root 2l by root 5 into g. Root 5 into g. Now, so which one option? Which is the correct one? Second one is the correct one. Next. And now, acoustic engineer places a sound detector on a railway station. A train approaching the platform with a speed of 10 meters per second. That means this is source, velocity of source. Now, the detector detects 10 kilohertz. That means frequency detected by the detector. That means observer is at rest. Now, if the train stops at the platform, then sounds the whistle, then most dominant frequency detected by it nearly. So, this is the observed frequency. Now, he is asking about original frequency. So, what is the formula for that? F equal to F naught into V plus or minus V naught by V plus or minus Vs. So, observer is at rest. Remove this term. This is moving towards so that V by V minus Vs. Now, substitute the values. So 10 kilohertz, 10 into 10 power 3 hertz equal to F naught into V value, 340. 340 by V minus Vs, 340 minus 10, 330. So F naught equal to 10 into 10 power 3 into 33 by 34. Now, so it may be 9.7 into 10 power 3 hertz or 9.7 kilohertz. First option. So this is not a original frequency. So this is the observed frequency. So when the object or train at rest, then that is the original frequency. Original frequency of the train, F naught. F naught you have to calculate, not F. Next, a satellite S is moving in an elliptical orbit around the Earth. The mass of the satellite is very small compared to the mass of the Earth. Now, so which option is the correct one? First one, acceleration of S is always directed towards the Earth. Next one, so eliminate wrong options. The angular momentum Angular momentum is always constant. So angular momentum of S about the earth, center of the earth changes in direction but not in magnitude. So for angular momentum, both the direction and the magnitude are constant. So that this is wrong statement. So he said that direction is going to change. So this is wrong. Next, the total mechanical energy of S varies periodically. No, total energy is constant. So that this is also wrong. Next, linear momentum of S remains constant. So which orbit is this one? Elliptical orbit. So elliptical orbit means that near velocity is different from far point. So velocity is going to change in elliptical orbit, but in circular orbit it may be constant. So linear momentum is not constant in elliptical orbit. Now, which option is the best one? Acceleration is always directed towards the center of the earth. So that is the correct one. Next one, a small sphere of mass m hanging in a uniform electric field as shown in the diagram. Now he is asking about what is the magnitude of the electric field. So if electric field is like this, then electric force, that is EQ, will be like this. Tension in the string along the string. So assume that this is theta, this is a T cos theta. This side equal to T sin theta. And this direction weight mg will act. Now write down the equation. In equilibrium, T cos theta equal to mg and T sin theta equal to EQ. Now take ratio between these two. Sin theta by cos theta, nothing but tan theta equal to EQ by mg. Tan theta equal to EQ by mg. Now, so check this diagram once. Now from this diagram, can you write the equation for tan theta? So here is the theta, this is D, this is L. Now if you want to write tan theta, this value you have to find. So this is equal to, so let it be x. So x square plus d square equal to L square, or x square equal to L square minus d square. So x equal to square root L square minus d square. Now tan theta value from this diagram, opposite side by adjacent side. So that means d by square root L square minus d square equal to EQ by mg. Now rearrange this one for E. E equal to mg into d by q into square root L square minus d square. So first option is the correct. Next one, electric charge Q is uniformly distributed around the charged ring of radius A. Electric potential is maximum on the axis of the ring. So like this. This is the axis of the ring. So where it will be maximum. So what is the potential formula? KQ by square root x square plus a square. So assume that this length is x. So radius is a. This is the formula. So when it will be maximum? If you substitute x equal to 0, then it will be maximum. Or at center of the ring, that is maximum. Potential is maximum at the center of the ring only. Next. So here, a 2 microfarad capacitor is there. Let it be C1. Is charged to potential difference of 200 volts. Let it be V1. And a 1 microfarad capacitor. Let it be C2. And charged to potential difference 100 volts. Let it be V2. Then the capacitors are then connected in parallel with opposite polarities are joined. With opposite polarities are joined together. Then common potential will be. Now what is the common potential? So for this one, common potential formula. So C1 V1 plus C2 V2 by C1 plus C2 is the common potential formula. So if opposite polarities are connected, then we need to write a negative sign here. Otherwise positive sign. If same polarities are connected, you have to write positive sign here. If opposite polarities are connected, so just substitute negative sign here. If second is uncharged, V2 equal to 0. Now substitute the values, then you will get the answer. C1 is 2, V1 is 200, minus C2 1. So V2 100 by C1 plus C2, that is 3. So 400 minus 100, 300 by 3. 300 by 3, that equal to 100 volt. Second option. Next. The potentiometer having wire 10 meter long is stretched and connected to a battery having steady voltage. A cell gives a null deflection with 700 centimeter. Now, if the length of the potentiometer wire increases by 2 meter, what is the new position? So EMF can be written as balancing length by length of the wire into potential. Balancing length by length of the wire into potential. Now apply this equation for two different cases. So in first case, balancing length is 700 centimeter. So 700 centimeter means no need to write, just convert, just write it directly as 700 centimeter. Now total length 10 meter. Can you write this one in terms of centimeter? 10 into 100. That means 1000 into V. Next, in second case, same battery, but this length is increased by 2 meter. So let it be X by, so 10 becomes 12. So increased by 2 meter means initially 10, increased by 2 means that becomes 12. In terms of centimeter, 1200 centimeter into V. Now take ratio between these two, then you will get the answer. 700 by 1000 equal to X by 1200. So cancel similar terms. Then X equal to 12 into 7 by 10 is a 6 by 5 into 7. So 6 into 1.2 into 7. 1.2 into 7. 1200 into 100 also there. So 840 centimeters. Next, in a coaxial cylinder, straight cable, the inner solid conductor and outer solid conductor carries a equal current. So coaxial means like this. This is a solid one. Similarly, so outside cable is there, that is also like this. Now current in outside is like this. Inside may be opposite to this one. Same currents. Both currents are equal and opposite. Now, so what is the correct one? What is the correct option? Inside the inner conducting expected axis, magnetic field is 0. Inside the outer conductor. Next, in between the conductors, outside cable. So outside is the 0, because if you want to calculate, we need to draw so a line that is that encloses these two currents. Then net current is 0 only. That is from which law? Ampere's law. Next, the maximum value of permeability mu is 0.126 Tesla. Then maximum value of relative permeability. So mu is given. This is nothing but a mu. Mu is given. What is the formula for mu? Mu equal to mu naught into mu r. Now from this one, mu r equal to mu by mu naught. Mu value is given as 0.126. Mu naught is 4 pi into 10 power minus 7. Now 0.126 by 4 pi into 10 power 7. So this one 0.126 by 4 pi. 4 pi is nothing but 0.126. 4 pi, 4 into 3.14. Nearly 12 only. 120, 12.6. 12 something. So in this one is equal to 10 power 7 by 100 times, that equal to 10 power 5. First option the correct. So here 4 pi is nothing but 12 only. This is also 12, 0.12. 0.12 by 12 means 1 by 100. 10 power 7 by 100, nothing but 10 power 5. Next, which of the following pairs of coils have zero coupling constant? Coupling constant is zero when coils are perpendicular to each other. Now check these diagrams. These two coils are perpendicular in the third option. Two coils are perpendicular in third option. So go through the third option. Next, a coil of resistance 100 ohms is placed in a magnetic field. Magnetic flux is given as 40 T square plus 8. Then current in the coil. Current in the coil at a T equal to 1 second. Resistance is given. So what is the induced EMF formula? Minus d phi by dt. Minus sign also there, but here answer only positive sign is there, so that I am taking positive sign. D phi by dt. V equal to I into R. IR equal to d phi by dt. R. I equal to 1 by R into d phi by dt. Now substitute the values. 1 by R. R value 100. Now d by dt of what is the phi value? 40 T square plus 8. This is a current I. Now I can be written as 1 by 100 into d by dt. Derivative of this one. Derivative of t square is 2t. So 40 into 2t plus derivative of 8 is for any constant derivative is 0 only. This is equal to, so 40 into 2, 80. 80 into t by 100. That equal to 0.8 into t. 0.8 into t. Now substitute the value of time t equal to 1. Then you will get 0.8 ampere. Next. The primary winding of an ideal transformer has 1000 turns. So this is nothing but number of turns in primary. And secondary 5000. Number of turns in secondary is 5000. Now primary voltage is given as this is nothing but a V primary. So he is asking about a secondary voltage V secondary. What is the relation between these two? Number of turns in primary by number of turns in secondary equal to voltage across primary coil by voltage across secondary coil. Number of turns in primary 1000 by number of turns in secondary 5000 equal to voltage in primary 220 by voltage in secondary. Now cancel similar terms. Then S equal to 5 into 220. So 0, 0, so 1100. Second option. Next. So which of the following among the following causes a greenhouse effect? Greenhouse effect is due to infrared rays. Next. So go through the statement. Statement A, 1 gram of ice at 0 degrees centigrade melts at 1 atmosphere. The change in internal energy is 80 calories. Next one, 1 gram of water at 100 degrees Celsius boils at atmospheric pressure. The internal energy is less than 540. So these two options are correct. Both statements are correct. So go with the first option. Both the statements are correct. Next one. Nearsighted man can clearly see the object at a distance 2 meters, then power of the lens. So this is how much focal length we need to use? Minus 2 meters is the focal length of the lens that need to use. So nearsighted person means which lens we need to use? Convex or concave? So negative sign is for concave lens. Next. So focal length is minus 2. Then power is how much? Power equal to 1 by focal length. So 1 by minus 2 that equal to minus 0.5 diopter. Minus means concave lens. Next, fringe width in Young's double slit experiment. Fringe width formula beta equal to lambda into capital D by small d. Lambda wavelength, capital D is distance between screen and the slit, small d is slit separation. So beta is directly proportional to wavelength. First option correct. Next, beta is directly proportional to distance, directly proportional to separation between the inversely proportional to separation between the slits. So correct one. Next, is directly proportional to separation between the slits. Wrong option. Directly proportional to capital D means that is the distance between slit and the screen. So this is wrong option. So 1 and 2 are correct. So fourth option is the correct. Next one. Resolving power of an electron microscope is operated at 24 kilowatt is X. Now resolving power of an electron microscope when operated at 6 kilowatt. So what is the resolving power relation? Resolving power is inversely proportional to wavelength. Resolving power is inversely proportional to wavelength. Now what is the relation between wavelength and the kinetic energy? This is kilovolts, na? Kilovolt or voltage. Wavelength and voltage 1 by lambda. H by P, na? Lambda equal to de Broglie wavelength formula. Lambda equal to H by P. Momentum equal to H by square root 2m into Q into delta. That means lambda is inversely proportional to square root of potential difference. So that we need to write this lambda is inversely proportional to square root of potential. So lambda is inversely proportional to potential. Now from this equation we can conclude that resolving power is directly proportional to square root of the potential difference. Substitute the values. So resolving power in first case is X. Resolving power in first case by resolving power in second case equal to potential in first case by potential in second case. Substitute and solve, then you will get the answer. So resolving power in first case X. By resolving power in second case you have to calculate root V1 24 by V2 6. So 4 times. Then resolving power in second case is X by 2. First option. Now go through the next one. Question number 40. An electron in a hydrogen-like atom is excited state. It has total energy of minus 3.4 electron volt. Then a de Broglie wavelength of the electron nearly equal to. De Broglie wavelength he is asking. Can you write de Broglie wavelength equation in terms of energies? De Broglie wavelength equation in terms of energy. So lambda equal to H by square root 2m into total energy, kinetic energy or total energy. So total energy is 3.4, minus 3.4 means kinetic energy is 3.4 electron volts. Substitute the values. 6.6 into 10 power minus 34 is the H value by square root 2m into electron mass 9.1 into 10 power minus 31 into kinetic energy 3.4 electron volts. Convert that one. 1.6 into 10 power minus 9. Solve this one further. Then you will get a 6.66 angstroms. Angstroms means 10 power minus 10. Next, a certain radioactive material can undergo 3 different types of decays simultaneously. Then, what is the effective decay constant? So, if 3 decays are there, then lambda 1 plus lambda 2 plus lambda 3. So lambda plus 2 lambda plus 2 lambda. 5 lambda. Next, electrical conductivity of pure silicon can be increased by silicon. Silicon means that is a conductor, insulator, or semiconductor. Semiconductor. That is a silicon or germanium. Both are semiconducting materials. So, our semiconductor. Silicon is a semiconductor. Now, if you increase the temperature, then electrical conductivity increases for a semiconductor. Next, doping also increases electrical conductivity. Radiating UV light, so that means some energy radiated on that one, like a light emitting diode. So all of these are correct. So for the fourth option you have to select. Next, so dimensions of ratio of electric dipole moment to the magnetic dipole moment. So electric dipole moment by magnetic dipole moment. Electric dipole moment formula Q into 2L. Magnetic dipole moment I into area, current into area. For charge, current I equal to Q by T. Q can be written as I into T. I into T into length by I into area. Now cancel I and I. Now T into 2L by area. Substitute the dimensional formula. For T, capital T, length L, area L square. So T into L power minus 1. So T into L power minus 1. Next. 34. RMS velocity of a gas at certain temperature is √2. √2 times that oxygen molecule at the same temperature, then gas may be. So RMS velocity of certain gas is √2 times the RMS velocity of oxygen. So RMS velocity of certain gas is equal to √2 times the RMS velocity of oxygen. So RMS velocity formula square root 3 RT by M. That means inversely proportional to M. 1 by root M equal to √2 into 1 by square root. What is the molar mass for oxygen? 1 by root M equal to 1 by 2 by 32. 16. Now M equal to 16. So M is 16 correspond to carbon 12, 4 hydrogens, 16. So CH4. The resultant of two vectors P and Q makes an angle alpha with P, beta with Q. Then, so what is the resultant of PQ? Two vectors P and Q. That is from parallelogram law. So assume that this is P, this is Q. Resultant making an angle, R is making an angle alpha. Then for this one, we can write tan alpha as now. Assume that this is making an angle beta. Now tan beta can be written as the status P with Q, Q with P. So P sin theta by Q plus P cos theta. Now, so check the options. P and Q making an angle alpha with and beta is Q. So among these four, what is the common condition? Alpha is less than beta. If alpha is less than beta, alpha is less than beta means which one is more? Alpha is less compared to the beta. So alpha is inversely proportional to P. So that so if alpha is less, then P is more. So third option. Next, an object may have varying speed without varying velocity. Varying speed without varying velocity. So if the speed varies, velocity also changes. If speed is going to change, means velocity also changes. So varying speed without varying velocity, it not possible. Varying speed. Next, varying velocity without varying speed. Varying velocity without varying speed. Varying velocity without varying speed. Possible in circular motion only. In circular motion, speed is constant but velocity changing. So this is possible in a circular motion. Next, third one, non-zero acceleration without having varying speed. So in circular motion only that is possible. Acceleration is there, but speed is constant. Now go with the second and third. So why don't we select first option, varying speed without varying velocity? So if speed varies, we cannot say sometimes velocity varies. Sometimes the velocity varies also. So if speed varies, velocity need to vary. If speed constant, in that case also velocity is varying in circular motion. Next, consider two block system in equilibrium as shown in the figure. Now draw the free body diagram for A and B, then you will get the answer. For B, now frictional force, so weight mg acts downwards. To balance this one, only one option is there. Frictional force need to act upward. Next, for A, weight of the block A acts downwards. Now, what about this frictional force? So here frictional force Fa will act upward. Now, what about between these two? So here friction acts upward. To balance that one exactly in opposite direction, Fb need to act downward. Now, so go through the option. Which one we need to select? The direction of friction on B due to A. Direction of friction on B. On B, what is the direction of frictional force? Upward. First option. Next one. The velocity of center of mass of the system remains constant if external force acting on that one is 0. If external force is 0, then velocity of center of mass is constant. So fourth option. Next, the equation of particle projectile is given by x equal to 36 into t. So x equal to, compare this one with u cos theta into t. So x equal to 36 into t. Now compare these two, then u cos theta is how much? 36. Now other equation, y equal to 48 into t minus 4.9 t square. Compare this one with u sin theta into t minus a half gt square. Then from these two, u sin theta equal to 48. Now what we have to calculate? Angle of projection. Now take ratio between these two. U sin theta by u cos theta. U sin theta by u cos theta equal to 48 by 36. That equal to 4 by 3. This is nothing but a tan theta. Tan theta is 4 by 3. Then that is equal to 4 by 3 means that is greater than 1. So 1 means 45 degrees. Greater than 1 means 4 by 3 is nothing but 53 degrees. Next, if 5 kg, a body of mass 5 kg is acted upon by a force minus 3i plus 4j. Its initial velocity is 6i minus 12j. Then time at which it just have velocity along x-axis, velocity along y-axis. Velocity along y-axis means velocity along x-axis becomes final velocity along x-axis should be equal to 0. Because what he is saying, So finally, at what time it will just have velocity along y-axis. Velocity along y-axis means velocity along x-axis should be 0. So use that condition. What is the given data? Force is given. What is the acceleration? Acceleration equal to force by mass. That equal to minus 3I plus 4J by mass 5 kg by 5. So that equal to minus 3 by 5 into I plus 4 by 5 into J. So this is AX into I plus AY into J. So AX is how much? Minus 3 by 5. Now, so this is first factor is here also same logic. U equal to Ux into I plus Uy into J. Ux is how much? 6. Now, final velocity from equation of motion V equal to U plus 18. Apply this condition along only x-axis. That means Vx equal to Ux plus Ax into T. Vx is how much? 0. Ux is how much? 6. Plus Ax is minus 3 by 5. Minus 3 by 5 into T. Now here in this one. So 6 equal to 3 by 5 into T. Cancel this one 2 times. So T equal to 2 into 5. That equal to 10 seconds.